Hi everyone, I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Engineering. Today we are going to see about asymptotic notations in design and analysis of algorithm subject. Asymptotic notations in mathematics, computer science and related fields, that big O notation describes the limiting behavior of a function when the argument tends towards a particular value or infinity, usually in terms of simple functions. So big O notation allows its user to simplify functions in order to concentrate on their growth rates. Different functions with the same growth rate may be represented using the same big O notation. The efficiency analysis framework concentrates on the growth of order of an algorithm's basic operation, count as the principal indicator of algorithm efficiency. To compare and rank such order of growth, computer scientist uses three notations: big O, big omega, big theta and little o. Here the time complexity of an algorithm qualifies the amount of time taken by an algorithm to run as a function of the size of the input to the problem. When it expressed using big O notations, the time complexity is said to be described asymptotically, that is, as the input size goes to infinity. Then running time of an algorithm as a function of input size n for large n, expressed using only the higher order term in the expression for the exact running time. Instead of exact running time, say big O of n square. Describe behavior of functions in the limit returned using asymptotic notation. The notation describes different rate of growth relations between the defining functions and the defined set of a function. So big O notation. Definition for big O notation is: a function n is said to be big O of g of n, denoted t of n belongs to big O of g of n. If t of n is bounded above by some constant multiple of g of n for all large n, that is, if there exists some positive constant and some positive non-negative integer n naught, such that here f of n is equal to big O of g of n. So look at the graph, and f of n is the function and g of n is the function. Always big O notation always belongs to the upper bound of the function, and n denotes the number of operations and t belongs to the number of times it executes the line. So for a big O notation, I'm going to solve examples. So as I already told that big O of n, the general formula is t of n is greater than equal to c of g of n for all n greater than equal to 0. Here example, n belongs to big O of n square and 100 n plus 5 belongs to big O of n square. Likewise 1 by 2 n minus 1 belongs to big O of n square. Also here n cube not belongs to big O of n square, and also 0.001 n cube not belongs to big O of n square. Also n power 4 plus n plus 1 belongs to big O of n square. Let us see another example. Let us formally prove 100 n plus 5 belongs to big O of n square. Here 100 n plus 5 less than or equal to 100 n plus n for all n greater than equal to 5. So 101 n less than equal to 101 n square. Here c take constant as 101 and n naught is equal to 5. Here we have to note that definition gives us a lot of freedom in choosing specific values for constant c and n naught. And strategies for big O: sometimes the easiest way to prove that f of n is equal to big O of g of n is to take c to be the sum of the positive coefficients of f of n. We can usually ignore the negative coefficients. Example, To prove 5n square plus 3n plus 20 is equal to big O of n square. Solution. Initially, you have to pick all the constants in this linear equation. So, c is equal to 5 plus 3 plus 20 is equal to 28. If n greater than equal to n not is equal to 1. So, 5n square plus 3n plus 20 is less than equal to, because big O always belongs to the upper bound of the function. So, less than equal to 5n square plus 3n square plus 20n square, which is equal to 28n square. So, f of n is equal to g of n. As the general formula, f of n greater than less than or equal to g of n. So, therefore, we prove 5n square plus 3n plus 20 is equal to big O of n square. Thank you. In next video we are going to see about what is big omega and big theta. Thank you.